Good evening, everybody. Well, this is the 16th International Conference on Climate Change, but this is my very first. Hopefully not my last. So they asked me to do a keynote presentation for tonight's dinner, and I asked them what they wanted me to talk about, and they said that I kind of had a little bit of free rein. And since I'm a meteorologist, well, I like to talk about extreme weather. So that's what we're going to do. Would you have a clicker? So a little bit about me. Craig already gave you the introduction, but I graduated from Millersville University last year, and I've garnered over 100,000 followers on X and another 30-some thousand on Facebook. And as my post went viral, I started getting attention from the media. Sometimes that's a good thing, sometimes not. And the New York Post's Chadwick Moore came down to my hometown and interviewed me and wrote a profile about me and called me the anti-Greta Thunberg. And I just thought that I'd give a little shout out to my buddies Dean Cain, the actor, and Nick Searcy. I got the chance, Dean is a good friend of mine, and I got the chance to film a couple scenes in an upcoming film that's going to be in theaters this fall, I think. So it's called End the Wait, and I'm not going to spoil anything about it here. So with that all said, why does the climate change debate matter to me? Well, I had teachers in high school and in middle school. They were wonderful, by the way. And I mentioned this in my youth presentation on the youth panel, and that they were not necessarily indoctrinating me intentionally. They were just education majors that went to college to get their degree, and they became teachers, and they were placed in science to teach science classes, and they taught from the textbook. And it was the conventional narrative that greenhouse gases are dangerously warming the planet, and that it's due to our fossil fuel combustion, and we're all gonna, die in 10 years, kind of. And I was a little worried about that, because while I grew up in a conservative family, and I have conservative political beliefs, I've always held true to that. I don't let my political beliefs color how I interpret scientific data. Because science does not care about your religious beliefs or your political beliefs, who you voted for. Science is science. And because of that, I just believed whatever the textbooks told me, whatever my teachers told me. And I had a teacher in 5th grade, and she was wonderful. But she told me that in 20 years from then, that DC, where we're at right now, is going to be underwater in 20 years. That was 13 years ago. Now, I thought that was awesome at first. It's like, I can go to the beach. I can only drive 50 miles. I don't have to go that far. But then I was a little worried about it. Well, if Joe Bastardi was here, I think he had to leave early. He would know all about this. December 2015, I was 12 years old, just before my 13th birthday. And it was an absolute blowtorch across the country. We had temperatures 5 to 10 plus degrees above average east of the Continental Divide there. And I made this map using weather station data from NOAA, and this is the temperature anomaly map. Now, I like to make my own maps with Python. I don't like that alarmist color scale that they provide on a lot of maps. So I made my own color table. It looks a lot more reasonable than bright red being 2 degrees above average. It looks like the Earth's on fire. So I thought this was a big problem. I remember sitting in church during the candlelight service, Harmony United Methodist Church in Hamilton, Virginia, and it was 70 degrees outside, and I thought that this was the end of the world. Now, my dad told me that it was around 70 degrees when he was 10 years old, and that would place him in 1982. That was Christmas Day, 1982. Now I thought, Dad, yeah, you're full of it. You're full of it. You don't know what you're talking about. Well, turned out that Dad was right. So here's the data for Washington, D.C. You can see that Christmas Eve in 2015 was a record. It was 71 degrees. It was 69 in 1933. But Christmas Day in 1982, sure enough, it was 70 degrees. And that wasn't even a record. The record's 72 from 1964. And then I started looking at this data because I realized that, well, Dad was right. And that these things have happened before. Climate goes in natural cycles. And the warmest December on record in U.S. history was probably in 1889. My great-grandmother wasn't born until 1914, so that was a long time ago. and temperatures across the United States. And I went and accessed GHCN monthly data, and I also accessed Fort data, which predates the Weather Service records. And I reconstructed this chart, and you can see temperatures across an even bigger part of the country. Maybe not here in the DC or New England, but it was still pretty warm, especially across the southern plains and the Ohio Valley and Southeast. Temperatures were 10 to 20 degrees above average, far warmer than it was in 2015. But I didn't know that until I started looking at the data. Now, the biggest inspiration for why I do what I do is probably the work of Dr. John Christie and Roy Spencer. I looked up to them since I was in high school. And John Christie always includes in his presentation this quote from Lord Kelvin, which is that all science is essentially numbers. And so Lord Kelvin states that when you can measure things and you can express what you're talking about in numbers, you know something about it. If you're just saying, I feel, I think, that's not real science. So one of the things I do for CFACT, and it's a collaborative effort with the other organizations, but I contribute to it, is the monthly climate fact check. And so I pulled some of my favorite ones from the last year or so that I've done. And this one's gold. The World Meteorological Organization, which is one of the United Nations organizations, they stated, and this tweet or X post rather is still up. They did not delete this. They said 2024 was the 10th year in a row that the global mean temperature record was broken. Now, their own chart doesn't even support that claim. You can see that if you now there's going to be a lot of disagreement here about the global mean temperature. There's a lot of debate about that. I'm not going to discuss that. But if you just accept this chart at face value for my point here, 2024 was the record warm year, whatever, by a few tenths of a degree. Who cares? But it was not the warmest. It was not a record-breaking year for the 10th year in a row. 2022 was cooler than 2021. 2021 was cooler than 2020, and so forth. So I can't believe that they still have that up. Then, of course, we had the LA area fires last January, and Governor Gavin Newsom, I think I made a typo there, I was supposed to say Newsom, he was at the COP30 meeting down in Brazil. He stated that California is on the tip of the spear when it comes to climate change. Simultaneous droughts and simultaneous floods. The hots are getting hotter, the dry is drier. You saw one of the most devastating wildfires in American history in the middle of winter in January. Oh no. Well, turns out climate change had pretty much nothing to do with that fire. In fact, the fire was caused by the rekindling of a previous arson-caused wildfire, who would have guessed, and it was stoked by the Santa Ana winds that caused the fire to spread. Now, recent California wildfire seasons, such as 2020's record-breaking year, pale in comparison to the seasons that occurred prior to European settlement. And there was this 2007 study, well, I'm getting ahead of myself. This chart here shows the U.S. wildfire burn area since 1980. Now, I know that somebody else, I forget who it was, had the 1926 chart, which I have that chart too, but I don't need it for this illustration here. But you can see that since the 1980s, there's been a slight increase in wildfires. Not much of a trend since the 2000s, and that's when, around the time that the U.S. Forest Service decided that we needed to continue doing prescribed burns. But in California, it's the red line there on the bottom. Now, what's interesting about this is that this 2007 paper found that prior to European settlement, 4.5 to 12 million acres of land in California, present-day California, was burned each year on average. So that's the range, that bar there. In some years, more land burned in modern-day California than burns in the entire United States in modern times. So that's the natural climatic state. Our fire suppression practices have greatly reduced fire risk. And ironically, in some places, it's actually led to more fire in recent years because of the buildup of fuels, especially small diameter twigs and leaves and stuff like that, that really catch fire and dry out fast when you get the downsloping winds. But what's interesting about California here is that 2020's record-breaking fire year was 4.2 million acres. That's not even the lower bound of what they expected, what you could expect prior to European settlement in the 17th and 18th centuries. So that's pretty interesting there. Now this one's my favorite. This is the Texas Hill Country floods. So last July, Independence Day, we had devastating floods from this mesoscale convective vortex that formed over Texas, and it dropped a whole bunch of rain on the hill country. And it caused the rivers in the area to flood, and 135 people were killed in the aftermath. 117 of them were in Kerr County alone. And of course, the news media, there's a whole bunch of articles about this. I spent like 3 weeks just debunking all this. But I chose one from NPR, and they blamed it on climate change. That's all they got. Every time the weather goes boo, it's climate change. I stubbed my toe, climate change. There's nothing original from these people. And their argument essentially was that climate change is driving more extreme rainstorms and that a warmer atmosphere can hold more moisture. And so they said today that heaviest rainstorms drop about 20% more water than they did in the late 1950s. So there's some numbers, and we can look at them. So their potential argument is based on the Clausius-Clapeyron relation. And Dr. Legates talked about this yesterday in a talk, if you were there for that, a little bit. And so there's the equation. I'm not going to go into what the variables mean. I'm sure a lot of the scientists here know what they mean, but the lay people don't need to. We don't need to go into that. But this is the curve of that. And essentially it states that for every 1 degree increase in air temperature, the saturation vapor pressure, which is essentially the amount of vapor that the amount of water that can evaporate into unsaturated air, increases by about 7%. And that's true. The problem with that argument, and I call them climastrologists because they're not doing real science, is, and these people never took a cloud physics course. I took a couple of them and passed with flying colors. But the problem with this argument is that Clausius-Clapeyron does not tell you how much rain falls, much less at what rate, out of a cloud. It tells you how much water can evaporate into the air before it gets saturated as a function of temperature. So it tells you nothing about how much rain falls, which is in a rate which is central to flash flooding. So I went into the NOAA United States Historical Climatology Network, and I looked at, and I made this map in Python. It's beautiful, isn't it? And I looked at US HCN stations in NOAA's United States Historical Climatology Network that have had data in both 1900 and 2025, and there ended up being 447 of them. And so I calculated what the median rainfall was in the entire 1900 to 2025 record. I didn't do the 30-year average, I did the entire record, 50th percentile, the median. Then I calculated what the top 1%, the 99th percentile of rainfall events would be, and looked at the percent change per year. Now, most of the map is gray or white, not much change over time. There are some places where you see a big increase. Now, if CO2, which is the supposed climate control knob, is causing all these, oh, I got a laser, look at that, that's cool, like a cat with a mouse. If climate change is causing the precipitation to increase here in western Minnesota, why is it causing it to decrease in eastern Minnesota? That makes no sense. So this is mostly natural variability that we see here. So there's not much of an increase or decrease. So if you average it all out, it's pretty steady. There's not a lot of statistical significance here. The whole map would be white in terms of the percent change per year. And what's interesting also is if we zoom in on Texas, the hill country, this region, there's no change at all in the heavy rainfall events. And in fact, if you go in and you look at, and I wanted to include this plot in here, but I forgot to do it because I meant to do it last minute, but I actually analyzed some stations in Texas. I analyzed about 20 of them, and I calculated the top 1% of rainfall events per year, and I calculated how much rain fell from those events in inches for each of those events. And the trend is actually slightly downward. It's insignificant, but it's slightly down. So that claim that we are seeing 20% more rain than we did in 1950, well, if you go back to 1900, the trend is slightly negative, insignificantly, but there's no increase. So that number was purely fabricated. And here, the EPA, I need to get in contact with Lee Zeldin. I really want to meet this man and I have some just wonderful ideas of how to do some great climate charts for the EPA. And one of the ones that they have on their climate indicators page, which has been rebranded, is the change in the magnitude of river flooding in the lower 48. Now, the EPA's chart begins in 1965 and it ends in 2015. And when I posted it online, people criticized it, and it was a good criticism that it was 10 years out of date. So I went a few months ago and I analyzed all the USGS river gauges and stream gauges that had data from 1960 to 2025 with, I think, 85 or 90% completeness. So there's not a lot of missing data. You want to have a thorough record. And I plotted the entire US. Some places are up, some are down, most are not significant. And actually, there's more stations with a significant decrease than there are significant increase, 22 versus 25, if I'm reading that correctly. And here in Texas, notice that there's not much of an increase at all in the river flooding there. It's actually downward. So that's a little inconvenient for their narrative. Now this one, I like this too. So we had a pretty cold winter this year. It was the coldest winter here in Washington, D.C. since 2002, 2003, which was my very first winter. Not to make anybody feel old or anything. As I said in my youth panel, I always identify as 55 plus so I can get the senior discount at IHOP. It has not worked yet. Maybe I need a mask of some kind, Mrs. Doubtfire style. So we had the cold winter, and if it's hot, it's global warming. If it's cold, it's global warming. And the New York Times wrote this article in their Climate Forward newsletter, where they said that colder colds and hotter hots, these are the intense bouts of unusual weather that scientists for decades warned would become more common with global warming. This is the temperature map I made of January. It was a cold month. Well, that's nonsense. They did not predict that for decades. In fact, this is the IPCC's 2001 third assessment report. Now, I have a lot of criticisms of the IPCC process, as everybody in this room probably does, but you can use it to your advantage. So this is the third assessment report, 2001, and they state that there will be fewer cold days and frost days over nearly all land areas, and that's the projected change throughout the 21st century, and they said very likely in their confidence interval there. And they state that an increase in mean temperature leads to more frequent extreme high temperatures. This is very nuanced because there are increases in some regions, but in some of the regions where you have a lot of data, and I want to show this on the next slide, such as the United States, Canada, there's actually a decrease in extreme heat. And there's reasons for that. And there's less frequent extreme low temperatures. So that's what they predicted, less frequent extreme low temperatures. They did not predict both more cold and heat. That's just an outright fabrication. So I went in and I analyzed the GHCN data, and I looked at stations with 85% completeness over the last 100 years, have at least 100 years of data. And I got 860 stations here that fit this bill. And I calculated heat wave frequency and cold wave frequency since 1895 to 2025. So this is January 1st, 1895 to December 31st, 2025. And then I calculated the intensity of these heat waves and cold waves using the average maximum temperature during the event and average low temperature during the cold wave events. Now to calculate heat wave frequency, this is the number of events per year. I did specifically May through September only because that's the warm season. And for cold waves, I did, I think, November through March. And in that, I calculated the percentiles relative to 1991 to 2020 climatology, and I did temperatures with maximum temperatures at least 3 consecutive days above the 90th percentile relative to that 30-year median. And then I did 3 consecutive days of the temperatures, minimum temperatures less than or equal to the 10th percentile for cold waves. So that's how I did that. So what we find is that if you take and this is supposed to say 1994 to 2025, I made a typo there. I was doing this like at 2 in the morning, so forgive me for that. So I calculated the average number of events per year for each of these. I did the 1901 to 30 average, and I did the most recent 30-year average, and I subtracted that from that. And heat waves have decreased by about 20.2% over the entire record in the lower 48. Cold waves have decreased more, particularly since 1989. That's that last big cold air outbreak that we had, and that's 31.5% decrease. So there's been no increase in the intensity either. Cold waves are about as cold as they always have been. Heat waves were much hotter prior to 1960, but you're not going to see that on a lot of charts. So I think the EPA could really use a chart like this. Now, this is another great chart. This was in the 4th National Climate Assessment. Now, I know that they have the 5th one, but the 4th one, this chart is really interesting, and they show the ratio of record high temperatures to record low temperatures, and they have this, interestingly, since 1930. That looks pretty scary. Looks like Greta Thunberg might be right. We see this increase in the ratio of record highs to lows, and that's figure 6.5 from chapter 6. And they state changes in the occurrence of record-setting daily temperatures are also apparent. Very generally, the number of record lows has been declining since the late 1970s, while the number of record highs has not been rising. So by extension, there has been an increase in the ratio of record highs to record lows, and so that they therefore conclude that the average of the ratio exceeds 2, so that means that there's more high temperature records and low temperatures being set, and therefore that's evidence of a climate crisis or something like that. Well, this is interesting because if you look at the actual number of record highs and lows, it looks something more like this. And I was able to do, I did a little bit different method here, and I got 711 stations, and I used, this is the lower 48 number of daily maximum temperature records, 1895 to 2024. And you can see this is the number of daily records total per station set in that 711 station data set. And you can see the 1930s and 1950s, even 1910s here, had a lot of extreme heat. And since then, it's generally declined or stayed steady. Number of cold records have also decreased, but not at quite the same rate. It's actually been faster, especially since the 1980s. Now, what's interesting about this is that if you compute this as a ratio of highs to lows, you get a chart there, and I did this back to 1895, but if you look at it since the 1930s, it looks very similar to the NCA chart. So because record low minimums have decreased at a faster rate than record high minimums, record high maximums is what I meant to say. Oh, it does say that. I cannot read. I think I need to get my eyes checked. They said it's a deceptive ratio that shows that they claim that record highs are increasing, when in reality, that increase in record highs doesn't actually exist if you look at the real data. And so what I'm going to end my presentation with here, the next couple slides here, is this claim by the Socialist Secretary General of the United Nations. Nobody ever seems to point out that he's a socialist. I don't know why nobody talks about that, but he stated on Twitter or X, that the world's addiction to fossil fuels is one of the greatest threats to global stability and prosperity. Now, I'll be honest with you, I don't care where our energy comes from. I'm a big supporter of nuclear power. That's what I actually advocate for. If there's any energy source I would advocate for, it's nuclear power. But the fact of the matter is that fossil fuels have afforded us wonderful things and technologies that have saved lives. And this chart here shows the CO2 emissions per capita on the x-axis, and the y-axis is the GDP per capita in 2022. And so it's very clear that, generally speaking, the more emissions a country has, the more prosperous it is because it's more industrial. And that's because of fossil fuels. And because of the technologies that it has allowed us to have with medicines and with life-saving equipment that runs off that power that we've developed, average life expectancy on every continent has more than doubled since the 19th century. Child mortality rate has decreased by over 65% on every continent since 1970. And this chart here is really cool. And while this doesn't say anything about climate, because obviously the climate hasn't necessarily gotten better or worse, but it just shows that we have been able to innovate and become more adaptable to extreme weather and resilient with warning coordination, with our building codes, everything like that. And despite the fact that the global population has increased by about 6 billion people since 1920, the absolute, this isn't normalized per capita. If it's normalized per capita, you get a 99% decrease. But if you just leave the raw numbers as is, despite the increase in population, the absolute number of deaths have decreased by about 96.2% over the last century. So that just shows that whatever the climate does or whatever nature throws at us, we are able to adapt to it. So we don't need these radical energy policies. We don't need to rapidly decarbonize. It's unnecessary, it's unproductive, and it's very expensive. And there's no evidence at all that we have a climate crisis. And I think everybody in this room, even if we debate the details, would agree with that statement. So thank you very much.